Hi, it's Jo Karen Hudson speaking. In this video, we'll talk about exponential expressions and polynomials. Let's start off with the definition. An exponential expression consists of a variable raised to an exponent. So let's look at some examples of exponential expressions. One example would be 5x squared. That's an example of an exponential expression. A second example would be negative 1/2 x cubed. And a third example would be y to the fourth power. Now let's talk about what the coefficients of these expressions would be. The coefficient is the number in front of the variable, so the coefficient of the first expression would be 5. The coefficient is the number in front of the variable, so the coefficient of negative 1/2 x cubed would be negative 1/2. The coefficient, understood to be 1 here, since there's not a coefficient showing, the number in front is understood to be 1. So the coefficient of y to the fourth power would be 1. Now let's see what we're talking about when we talk about the base. The base of the first expression, 5x squared, the base is x. That's what the exponent is resting on. The base of the first one is x. The base of the second one, negative 1/2 x cubed. The base of the second one is x. The third one, what the exponent is resting on is the y. And the exponent in the first expression, the exponent rests on the base, it would be 2. The exponent on the second expression, negative 1/2 x cubed, would be 3. And the exponent on the last one, y to the fourth, would be 4. Exponents are also called powers. So let's evaluate the following expressions. First, we want to evaluate 5x cubed when x is equal to 2. So I'm going to write down my 5x cubed. I'm going to wrap my variable in parentheses because that's where I'm going to plug in the 2. So I'll have 5 times 2 cubed. Remembering my rules of order of operations, please excuse my dear Aunt Sally. I have to do exponents next. So I'll have 5 times 2 cubed, and 2 cubed is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So now I'll have 5 times 2 cubed is 8. So when I evaluate this expression for x equal 2, I will come up with 40. Example 2, we want to evaluate the same expression for x equal negative 2. So I'm going to write down my expression, 5x cubed. I'm going to wrap my variable in parentheses, and then I'm going to replace the x with my negative 2. So I'll have 5 times negative 2 cubed. Negative 2 cubed would be negative 2 times negative 2 times negative 2. Negative 2 times negative 2 would be 4, and 4 times negative 2 would give us negative 8. So now we'll have 5 times negative 8, and 5 times negative 8 would be negative 40. And you see the answer is different. You have to make sure you're dealing with the negative. The answer is different. When you plug in positive 2, the answer is positive 40. When you plug in negative 2, the answer is negative 40. That's because we raised to an odd power. When you raise a negative number to an odd power, it's going to turn out to be negative. Okay, let's get another definition. Definition of a polynomial. A polynomial is an expression that has one or more exponential expressions that are being added or subtracted. The exponents must be whole numbers, which means there can't be any negatives. There can be fractions in the coefficients, but not in the exponents. And there can't be any variables in the denominator. The highest exponent is called the degree of the polynomial. A polynomial is classified as a monomial if it has one term, a binomial if it has two terms, a trinomial if it has three terms. Polynomials with more than three terms are just simply referred to as polynomials. For each expression, determine if it is a polynomial or not, and if it is a polynomial, give the degree and the class. So let's look at our first expression. Example 1, x cubed plus 1/2 x squared minus x minus 1. Is it a polynomial? Well, let's think. Are the variables whole numbers? Yes, they are. They're not negatives. They're not fractions. They're all whole numbers. This one is understood to be 1. The variables are all whole numbers. They're not fractions. And there are no variables in the denominator. So, yes, this is a polynomial. The highest exponent is 3. So that's the degree. The degree is 3. And it is classified as a polynomial because it has more than 3 terms. Example 2. X squared minus 5 over x. Is it a polynomial? It is not a polynomial, and the reason why it is not a polynomial is because it has a variable in the denominator. So we don't have to give this, and we don't have to give this, because it is not a polynomial. Let's look at example 3. Is it a polynomial? Let's see. All of the exponents are whole numbers. There's not any that are negatives. There's not any that are fractions. And there are no variables in the denominator. Yes, this is a polynomial. And the highest exponent is a 10. So it is degree 10. It has 3 terms. So it is classified as a trinomial. Okay, example 4. Is this a polynomial? Well, we look immediately and we see that there is a fractional exponent, so it is not a polynomial, so we'll not have to give this and we'll not have to give this. It's not a polynomial because we can have no fractional exponents. Example 5. 5x plus 2. Is it a polynomial? See, the exponent on this one is a 1. All of the exponents are whole numbers. There's no negative exponents, and there's no variables in the denominator. So yes, this is a polynomial. The highest exponent is this 1 that's understood. It's degree 1, and it's classed as a binomial because it has 2 terms. Example 6. The number 7. Now when you have the number 7, it is understood to have x to the 0 with it. The exponents are whole numbers. They're not negatives. They're not fractions, and there's no variables in the denominator. Yes, this is a polynomial. It is degree 0, and it is classed as a monomial because it only has 1 term. Example 7 is the last of these examples before we start simplifying a polynomial. This one is not a polynomial because it has negative. We have no negative exponents. Polynomials have no negative exponents. So we don't have to answer this. We don't have to answer this. Okay, simplifying a polynomial. When we simplify a polynomial, we want to combine like terms by adding or subtracting the coefficients and keeping the variable parts the same. And it's customary when we are simplifying a polynomial to write the terms in descending order from the highest exponent to the lowest, writing the highest one first. So let's start by simplifying example 1. And these are written in the correct order. They are written in descending power, so I'm going to add the like terms. 1x squared and 2x squared would be 3x squared. Negative 5x and plus 6x would be plus 1x, or I could just write 3x squared plus x. Example 2. This one is not written in descending power, so I'm going to find the biggest one first. And there's no others like that, so I'm going to start off with 3x cubed. And then I see that there are 2x squared terms. So I have negative 1x squared, which is understood, and negative 5x squared, which would give negative 6x squared. And then I have these numbers, 4 plus 2, and 4 plus 2 would be 6. And example 3, I want to add, I see that the highest exponent here is y to the 4th, so I want to combine 2y to the 4th and negative 3y to the 4th, which would be negative 1y to the 4th. And then I have this lonely y squared term, negative y squared, and then I have to add 1/2 plus 1/3. And it's not necessary to write the negative in front. I can just write negative y to the 4th minus y squared. I have to change the 1/2 and the 1/3 to a common denominator, as 6 is the smallest common denominator. Let's see, 2 times 3 is 6, and 1 times 3 makes 3, and then 3 times 2 makes 6, and 1 times 2 makes 2. So I'm getting ready for my final answer. Negative y to the 4th minus y squared plus 3/6 plus 2/6 is 5/6. This concludes the video. It's Jo Karen Hudson. Thank you, and have a wonderful day.